We are going to be starting off with integration and a basic overview of what it is. So, simply put, integrals tell us the area underneath a curve. The integral of a curve between the two x-bounds is going to give us the area between the curve and the x-axis. Remember, integrals are also useful for telling us or for giving us a way to find the original curve. Remember, if we integrate a derivative curve, we are going to find the original curve, or the curve that correlates to that rate of change. And we'll get into that a little bit later too. Remember, the integration is the opposite of differentiation. So typically, the diagram that I like to use is if you have your function and you have your derivative function, you can derive your original function to get the derivative function, but you can integrate the derivative function to get back up to the regular function. So as it says here, you're starting with a gradient and getting to the original function instead of the other way around. Now, the hardest part of integrating in Specialist in particular is knowing which method or which combination of methods to use. Because obviously, when we're going through integration in methods, we kind of have like a few different rules that we apply, like the power polynomial rule, the trig rules, sine and cos, then using logs and exponentials base e. But other than that, we don't really have anything that requires a lot of problem solving. It's more so just like an application of formulas. And maybe you'll have to rearrange things or like use some algebra somewhere. But it's pretty straightforward once you get the hang of it. But with Specialist, it gets like exponentially more complicated, right? Because we have all of these different methods to use. Often we'll be asked to use like a few different methods for the one question. Some of them are a little bit tricky to understand or a little bit tricky to apply. But again, the hardest part is knowing which one of these to use, because often looking at an integral at the face value, you can kind of like think of 10 different ways that you could do it, and all of them seem like they have an equal chance of working. At least that's how I used to feel, and that is still how I feel doing maths at university. So today I'm going to be going over briefly how to execute each method, but I will have a focus on like when to use each one, just because I feel like you can learn how to do each method from a textbook. So we will go over the methods in detail, but knowing when to use each method really is like the trickiest part. And because I practiced integration so much in year 12, I feel like I have a really good insight on providing information about like when to use each one, which ones to combine, like patterns to recognize when you're doing integration, all of that kind of stuff.